Hello future tech leaders, I am Sindhuja. Based on my own experience, I know that learning the right skills can shape our future. What if I say learning was as thrilled as the tech world itself? There we go. A cloud foundation, that's exactly what you will experience. From day one, you will be immersed in the interactive sessions and expert-led courses that covers most of the widely used technologies in the zone of data science to cloud computing, which brings more light to the life of a techie. I'm so excited to help you and unlock the true potential of a technology. Well, then why to wait? Let's see what it unfolds.
If you look at module number 13, this is about container instances and Azure Kubernetes Services. You're not using AKS, but you're using Service Bus. I didn't go over the Kubernetes few videos, and I did work on it and creating containers and bringing up the recycling. I mean just serverless services. I did that part. If you look at your AKS environment, first of all, once you look at your services, like Guru rightly mentioned, there will be a lot of services today which are broken up into smaller components or smaller set of services. Now, whenever you have these smaller set of services, even managing multi-tier applications was becoming difficult at certain point in time. Right. How many instances of the application or presentation tier? How many instances of service tier that we should have? How many instances of the databases should we have? How do we manage caching for those resources? We had struggled in past for these resources today. Once we have stabilized in those areas, we have a new challenge and on hand, which is dealing with microservices. Now in terms of microservices, the challenges will remain same. The challenges will remain same, but the answer will be different. The answer over here will be using an orchestration solution. How do you orchestrate or communicate between these small services? Earlier we used to go for WCF kind of environment or RPC based communication between components. Right. Now, those kinds of things also do exist within these microservices. Along with this, once it comes to communication, there has to be a mechanism of storing or running these resources, running these small applications or microservices. How do I do that? That will be done by using containers. And thanks to Docker, the team has already put in all the required details at one place. You don't have to like other open source solutions. You don't have to look for different set of components for each member here. Right. Once you look at Docker, anything which is required in terms of creating a container image or creating a runtime instance, runtime environment for it, right? Having an entire registry for putting all those images. Mechanism of retrieving those members, everything at one place. All these things given by a single vendor, and it becomes easier for us to work with it. Right? Now keeping that as a base. What Google has done is they came up with something called Kubernetes architecture. Right? And using this Kubernetes architecture, they have brought the power of containerization to the entire world. Now, once that is being leveraged by Google itself, it is made available to number of other organizations. Small size organizations, mid-size organizations, what they can do is they can make use of Kubernetes as a platform, implement it in their own Kubernetes cluster implement Kubernetes cluster in their own environment. Right. And that will help every organization to leverage benefits of Kubernetes. Whether you run this on Azure by using EKS or run it on AWS by using EKS or run it on Google itself by using GKS. But it will require is compute, storage, networking. Do you agree with me? All three. All three. Whichever vendor can give you this in at a cheaper rate and with better performance. If you want to do that, you can see that you can use the third option. Let's go with it. Right. In terms of creation of resources, management of resources for microservices, you have two members over here. One is Service Fabric. Within Microsoft, you have two options. One is Service Fabric and second is AKS. Along with this, the third option that you have, I'm not sure if this is what gives you complete orchestration. But for some kind of spike scenarios, or if you look at a stopgap kind of arrangement, right, where I have too much of a request coming, I would want to create some instances and allow people to access it or allow my AKs to take up that load. Then I can use something called as container instances. The two options available for us in context of Azure Kubernetes Services. Sorry, in terms of containers within Azure platform. If you want to see the complete hierarchy over here, I would recommend we should go to Azure where you see the complete set of solutions available for containers. AKS container instances. These are two things which are discussing right now. Apart from this, your Service Fabric container registry. Like you have your Docker Hub. Shinda would know this. Like you have your Docker Hub environment. Similarly, you have container registry over here. You can run these containers within container instances, the web for containers. You can write inside Azure functions. Then you have your OpenShift. Right. These are the options available for containers within Microsoft environment. You can do that. You can do that. You can do that. In terms of configuration of Kubernetes services, actually we don't do any configuration. Why am I saying that? Anyone who has done this configuration locally would know that. Chinna, did you get chance to set up complete Kubernetes on premises? Yes, actually I have created a Linux. I did created a Linux environment, a Ubuntu. From there I have spinned over a few pods. I did that. Anyone who has done that would know what is meant by configuration of Kubernetes. In terms of AKS, actually we don't do anything. In terms of AKS, it's a pretty interesting. Filling the part and like cleaning up the part. Here you already have a predefined template for you. Then you just have to fill in set of values in terms of how many child nodes do you want. The master node is already given to you by Azure. What is the child nodes that you would want? What are the components that you would want to initialize over here? What is the authorization mechanism that you'd want over here? Right. All these things are being taken care of by Azure itself. You don't have to do much over here. And secondly, Azure does not charge you for the master node. What will be charged for is the number of child nodes and the size of child nodes that you are creating. Right, that's the charging model once it comes to your Kubernetes environment. But current scenario, based on my experience, any implementation of containers, people always prefer going for Kubernetes. because something which is now, it has become an industry proven standard for everybody. And there are many success stories over here. People would not want to evaluate a new product. I'm not saying they are not new products. Like I said, you have Service Fabric available. You have Mesosphere. You have Docker Swarm, right? There are other tools for container orchestration. Question to you. Watch here. Now we have Kubernetes and we have got Azure Service Fabric, right? I know this is Kubernetes, is IaaS and service packages PaaS platform based. Correct. Correct. Where is that we use this? Like you know what kind of situation? What is the scenario we use? Use what? The service versus Kubernetes. I understand Kubernetes like where we can use, like no service. Like if I have to auto scaling, I have to scale like now 100 servers like now for it. For some go live stuff. And I use that Kubernetes and spin it and get the things done and bring them down. Where do we use Service Fabric? That's a great question. Let's go back a bit. When containerization started, while the entire industry was working towards Docker and they were working towards Kubernetes and all those things, Microsoft initiated their own mechanism over here using Service Fabric, where they said we for people who are from any T background, right? Using any T framework, right? And we will give them set of pre-existing interfaces and classes. They can extend from it. They can write code inside that, right? And whatever business logic they write, we will run that as a container within Service Fabric. We will run that as a container within Service Fabric. And this was not a Docker container. By doing that, by what Microsoft's focus was building a microservice application. How you can create number of classes, number of objects of that, create number of components over here as microservice, component integrate, interact with them using code. That was the primary focus of Microsoft. But, and that's where they came up with Service Fabric. But the way how Kubernetes took up and how Docker took up, it stripped the complete market. Later, what Microsoft did is they had only two options. One is shelf this entire Service Fabric and say we don't have any Service Fabric anymore. Or they start supporting Docker container. And that's what they did. Now, if you see a model in Service Fabric, you have both these models available. Either you create your own services by using any T framework, any T core, that's one. Or second approach is you go for hosting a Docker container inside Service Fabric. I think looks like the solution. What we have in on-premises with the service bus integrating, orchestrating all the microservices like that's what the fabric is, right? If you see the architecture wise, whatever Kubernetes does, Kubernetes master, Kubernetes child nodes, same architecture is Service Fabric also. Which means there will be one master node where all the classes, all the details have been registered. Correct. And there is a UI for it called a Service Fabric cluster. Through that Service Fabric cluster, you will be able to see how many child nodes are there. On each node, which services are running, which are the IP addresses, which are the load balancers which is being created, what are the IP addresses or DNS of each of these load balancers. All that information is available on Service Fabric cluster. The actual service is running inside the child nodes, the VMs that you have. This is too confusing. For example, now we have got Service Fabric and we have got Docker content. Image. We have got Kubernetes services in Azure, right? And I know an Azure Container, Azure Fabric. Where do we use? Are we having any labs for this in any of the? Because I'm not seeing anything in the 303. But do they have anything in the other places? For a case and a Service Fabric. You have labs for it. No problem with that. Now, China, to answer your question, what is the kind of architecture you want to build? You want to build a cloud native architecture or you want to build a cloud agnostic architecture? When you say cloud agnostic architecture, which means today I have my entire setup running on a case. Tomorrow I can move this to EKS on Azure. If that is what you want to achieve, then don't use Service Fabric. In that case, go for your Kubernetes environment. Because that Kubernetes, you can deploy it onto AWS, Azure, and also on Google Compute. You are never stuck with any vendor. You can move freely from one vendor to second vendor and forget cloud. You can also get it on premises. You can run this thing within your micro K test. Even it will work there also. But the number of nodes will be a problem once it comes to scale. Does it answer your question? It looks like Service Fabric is already an outdated solution. I can say, you can very clearly say that, but Microsoft will never say that. They want to sell their product. Why would they say it's outdated? But in the industry, if you see maximum people who are going for microservices, they will always prefer going for a case. Whenever they have a choice between Service Fabric. Now, if I have a lot of code being done, because initially I said there are a lot of coding happening on creating microservices via code. A lot of people who have that kind of large amount of code being written, they cannot go to Kubernetes. It will not work for them. What they would want to do is they would want to continue using Service Fabric. They might lose like future flexibility in case if they have to move. That's why people don't want to go for Service Fabric. Even people who are there with Service Fabric, slowly and steadily they are migrating to containers, converting that code into a server. My Docker-based code and then moving over here, and which is possible. If you look at AKS, how this works is you have your dev and test environment, whatever you would want to use. You can use your GitHub environment or your Azure repos for your source control. Dev and test environment. You can use Azure repos for your source control. Using Azure pipelines, we can convert this. Add this code into the container image. Push it to Azure Container Registry or Docker Hub, wherever you want. And then, using your AKS, environment and master and child nodes that we have, we can go ahead and do the deployment. How many containers are running? You want to see the complete graph of it. All that thing will be part of your Helm charts. where you can see the complete workflow over here, how you deploy this entire thing into a CI/CD banner. Those things you can perform by using Helm charts. There is options for dev spaces and all, but I have not used it as yet. Because for me it becomes easier to use my own developer environment. Use a Windows VM or Linux Windows VM or Linux VM. Create resources within that. I have not used it as yet. And with Docker runtime environment and the Docker commands which I have, it makes life easier. I have not gone into dev spaces as of now. These are additional services given by Microsoft. Yes, I have used. Using DevOps, what we can do is run those commands, that image creation commands or Docker build commands. We can run those smoothly using DevOps, which will help us to create an environment here. If you look at the execution, now this is how the entire master node we have already understood. This is the child nodes. Within child nodes, what you'll have is execution of your resources. Within your child nodes, the child virtual machines that you have to do that. Just one point which, before I forget it, China you're mentioning about. AKS is a IS resource infrastructure service resource, which is actually not true. AKS basically is a PaaS resource. Service Fabric is also a PaaS resource. Now, why am I saying it's a PaaS resource? We are choosing child nodes over here. The management and the communication is taken care by Azure. It's not done by you. You instance as a develop as an administrator. We don't have to do it. Any kind of patching on those operating systems, even though those things are taken care by Microsoft. You can't do an RDP. Sorry, go ahead. We can't do an RDP, but we will create them correct. Yes, even if you go for our app service plan, even within app service plan, we specify what kind of OS we want. We specify how many number of instances you want. We specify what will be the auto scale options here. But internal management is taken care by Microsoft. As for my understanding, both of these, even if you go for Service Fabric, there also you have to specify the nodes. How many nodes you want child nodes. But both of these are as services because underlying management is taken care by Microsoft. If you look at the pools over here, if you look at the node pool over here, this will be collection of number of resources. Now within that pool, how many virtual machines do you want? You can mention that within each of these virtual machines, you'll have your Docker runtime. And on that Docker runtime, you'll have your Docker containers which are running. Now, along with these containers, you also have one more logical layer on top of them, which is called as pod. One pod can have multiple related containers. There could be an application like if you see microservices. One pod will have the web application or the UI component. Second, pod will have the data store, right, which is required for running that showing that information, right. Both of these can be inside the same pod. In terms of deployment model, if you see all this deployment is done via YAML. Inside this YAML file, you have all the details which is required for provisioning this resource and executing it. There is no labs over here. But I can still help you work with this. Let's go to Azure documentation. Within Azure documentation, let me go to containers. Within containers, let's go to a case. Within a case, you can go to Azure CLI. Now, whichever way you want to create your environment using Azure Portal or Azure CLI. You can see no issues with it. Let me share this URL with you all. Just go to the URL. We still have 15 minutes on hand. At least let's complete this AKS part here. Let's go to Kubernetes Services. Within Kubernetes Services, let's create a new Kubernetes cluster. Resource group Subhasha G. Whatever name you want to specify. Southeast Asia. Availability zone. I don't require because anyways, I am going to create only one node here. Single node cluster. Container registry not required. I don't have a container registry right now. We are going to create a new node. Let's go ahead. Pools. As far as agent pool is concerned, we'll leave it as it is. Authentication. Service principal. As far as networking is concerned, use Azure CNET. Let's go ahead. Integrations, I don't need anything. Logging, I don't require. Disable that. Let's go to review and create. Let's go to review and create. Once the initial validation is being done, make sure you click on create. Let's proceed further. While this is getting created, still this will take some time. Once it gets created, we can go to Cloud Shell. I hope all of you all have. Both of you all have the Cloud Shell storage account still intact. If not, it will ask you to. Go ahead, go to Bash. This will take some time. This part which is getting credentials of AKS, this I can do. kubectl I can do right now. But what I can create is this part, that is creation of a YAML file. Now if you see this YAML file, it clearly mentions about what are the resources that you want to create. And if you see the services over here, there are two services. One is a back-end service and second is a front-end service. two services over here. Right. What is the kind of container you want to create behind the scene? What will be the CP or memory? Right. All these things we can mention over here. What is the image that we want to take over here? Radius. And this is the image which you are picking from MCR Microsoft Com. Similar to your Docker Hub environment, you also have Microsoft Registry. Similarly, you have a Google Registry as well. You must have seen that. Depending upon from which image registry you want to get those resources. Let's move ahead. Let me create a file over here. We'll use a third one, a vazure-vote.yaml. Let's copy the content from here. It is. Have you all worked with Linux earlier? Shetna would have worked. Guru, how about you? What is the DML file? I did actually. My initial. Using the VI editor. Create your file. Azure-vote.el. I was facing initial lot of hiccups for this Linux environment. With .NET Core and everything moving into Linux, it became difficult for me. But slowly instead, I have learned that. Now I know some commands of Linux. I love 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 Linux. It means love. In my case, I was being cheated in love. Microsoft said we will always promote Windows. Suddenly Microsoft said we love Linux also. Because they move from good actually. They're owning actually. They're not. They're owning a lot of things. We'll come up with .NET Core and everything. We have got the AKS environment ready. Slight change which I need to do because I don't have the same resource group. In my case, the name of the resource group is different. No problem. I will modify that. Get credentials resource group. It is a resource group. Subha Shaji, if I am not mistaken. Name of the cluster is same. AKS cluster. As we have got these credentials. Now we can go ahead and check for other commands over here. How many nodes we have? Right. Similarly, there are a lot of other commands as well. How many services do we have here? Kubectl get space services. The entire Kubectl is installed. You can make use of that. Let's go ahead. Publish this YAML file or create the services within your Kubernetes environment. Kubectl apply. It gave me a hard time. Actually, this is a pretty easily implemented in a PowerShell. I know that I have the install open too, and like I had a software, I was trying to, I know Red Hat and trying to get a free version of it. Like when it was like, no, it was not pretty. I have to. But here it's pretty simple. Like we have a power challenge. Log in and start doing it. That's what I told Gru earlier as well, that the configuration of Kubernetes is nothing actually here. Unless you start onto a Ubuntu machine with a fresh OS, and then you know what is configuration of Kubernetes. I don't want to go there. For certification purpose. Do we need to do that? No. I think you get 1 or 2 questions in there. Once this is done, check for what is the public IP being assigned over here. Here you will see there is an external IP. Let's copy this IP. This has already provisioned your application into a pod. And you will be able to access it over here. It has a load balance of service. This is a load balance of service. Simple, straightforward. But again, this is only one container here. If you have multiple containers, you have to do orchestration between them. There are a lot of other things that one needs to do. You can go to the next set of sections over here. How do you scale an application? Update applications. On your left-hand side, you have all the required stages for it. You can try this out. We'll stop with this for today. And will do. And finally, do not forget to like, share and subscribe to our channel.